x dx is, yep, just going to substitute. So negative 1 on 16, and then put the u in, du, over square root of u squared. Any questions there with what I've done? That all makes sense? And then this cancels out, this cancels out. It's just the integral of 1 du, and therefore the answer is, whoops, just u plus c. So the answer we're looking for is negative square root 9 minus 16 x squared on 16 plus c. Any questions? So you're very close. If it was 1, it would be inverse. And you need to know the formula for inverse as well. It's inverse sine of, like, you know, x squared on, x on a. Y. This one, okay. Interesting, I don't know. Let me think. Let's run through everything we know. It's definitely not a log. U substitution, I can't see that working out. What else do we have? See, so I'm as stuck as you guys, right, when you see this question? But I run through things. Completing the square, nah. Partial fractions, no. By parts, probably not. But I mean, if that's our last choice, that's our last choice. What can I do? I've got nothing else left. Anybody got this one out?
Yeah.
Yeah. And look, what'd you get? And Ben, how'd you guys do it?
Yeah, I kind of skipped this one.
Doesn't matter. You did something. So tell me, maybe I'm wrong. I might not see what you're seeing.
Maybe a trig sub, something like that.
Trig sub. Cool. Did you do that yourself?
I didn't get very far.
Okay, but you did something there. Fair enough.
I did substitution, and I just like kind of did something. I'm not too sure if it's the right answer, but
I think substitution, I can see it working out. So don't worry, I just wanted to see what you guys would think. When you run out of all options, right? I went through everything, integration, by parts, I went through partial fraction. Right? If everything fails, there's only 1 or 2 options left. It's either it is by part, which I don't think so because these are both algebra, so it probably isn't, or it's the substitution, either trig substitution, T formula sub, or algebraic substitution. T formula, there would be a sine or cos, so you definitely know it's not T. When you get into your trig substitution, if you wanted this to be a trig substitution, you probably want it to be something like this. Why? Because when you say x equals to sine, you get 1 minus sine squared, which is cos squared, and then cos squared and then root will cancel out, blah, blah, blah. So, Greg, I think yours, what did you let your u be? U equals?
I did u equals x plus 1.
Yeah, I think that's pretty good. du equals dx. X squared is u minus 1 all squared. Dx is du on u. This looks like a big mess. You can't do it yet. You have to expand. U squared minus 2u plus 1 all over u, all over u, all over u. And now we're pretty close. It's the integral of u minus 2 plus 1 on u. And what's your final answer? What's the integral of u? U squared on 2. Integral of 2 to u. Integral of 1 on u. Log u plus c. You still haven't got full marks because you have to substitute your u back in. So x plus 1 squared on 2 minus 2. X plus 1 plus log x plus 1 plus c. So just that first step, I know it. Because, you know, Anouk said trig sum, for example, and then there's just a big mess. If you knew, yeah, it's okay. We can fix the stuff. So it's still on. That's not a problem. Any questions? The next one, what do you think it is by looking at it straight away? That is a definite bypass. Why? You got algebra mixed with exponentials. That's a definite bypass. Okay, so triple I. U equals laity, don't forget. Given the choice, go for algebra first. So U equals X, du equals dx, dv equals ex dx, v equals ex. Any questions there? And then obviously your answer, your I, is this times this, x times ex. Because it's got limits, you put the limits in. Log 3 and 0 minus 0 to log 3, you still have to integrate ex again. And obviously your final answer is log 3 times e log 3, which is times by 3. And then minus 0, which is nothing, minus, and then again, ex log 3, 0, 3 log 3, minus, open big brackets, e log 3, plug it into your calculator, should give you 3, minus e0, should give you 1. And then the answer is 3 log 3 minus, so 3 minus 1 is 2, and then negative 2. You could have done that. I know you could have. You had to just realise that was by the path, and that's it. That's a shame. Done. Next one. Oh, well, any questions about that one from anyone? Okay. B, I. Equating coefficients. So 2 equals A t squared plus 1 plus bt plus c t plus 1. And then usually we would let t equal to no, you wouldn't let it equal to 0 straight away. You would let t equal to negative 1. So you can get rid of this component. Let t equal to negative 1, then you end up with 2. Negative 1 squared is 1, 1 plus 1 is 2a, and then this is gone. So a should equal to 1. Then you would let t equal to 0. After you cross out all the factors, which is gone, now you let t equal to 0, you end up with 2 equals a, right? A times 1 is a, plus 0, c. A is 1, therefore c equals to 1. And last one, equate coefficients of t squared, which would be 0, because there's no t squared here, a plus b. A plus b, which means b would equal to negative 1. So see, I think when you're marking at home, you probably give yourself 0 for that. No, it's not, you've done everything right, except just at the beginning. So you get 2 out of 3. But anyways, that's why I'm going to mark your window. All right, any questions?
Was that 3 marks?
That was 3 marks.
Okay.
Hence, integrate it. So double I, oops. Hence integrate, so the answer would be what? A, so 1 on, so the integral, 1 on t plus 1 plus b. b is minus 1, but I don't like that when I've got a plus. So what I do is leave it as a plus. Minus t, then you won't get it wrong, plus c. Over t squared plus 1 dt. Okay, I'm sure by now we're used to what this one is. What's 1 on t plus 1?
ln t plus 1.
Right, that equals to ln t plus 1. But what about this guy? Now that, we know if we differentiate the bottom, it gives me 2t, which is good. There's a t there, but still got a plus 1. So that is not just a log. What's the method for this? What are we meant to do? Yeah, split it up. That's the one. So minus, let's just say, maybe I might just, so that we don't get anything wrong, leave it all. Leave this one in. And then if I'm going to split it up now, I know that the minus is only attached to the t, not to the 1. So it's minus t on t squared plus 1, and then plus 1 on t squared plus 1. And then I'm pretty much done. Log t plus 1 minus half log t squared plus 1 plus inverse tan t squared plus 1, subbing my limits of 0 and 1. Anyone get the actual final answer out? You can help us out.
I did, but it doesn't look right.
Log 2 minus half log 2 plus inverse tan of 2 minus log 1, which is 0, minus half of log 1, which is still 0, plus inverse tan of 1, which is 45 degrees. Is that what you got, roughly? Log 2 minus half of log 2 is something like this, 3 on 2, log 2, plus inverse tan of 2 minus inverse tan of 1.
I changed inverse tan of 1 to pi on 4.
Yeah, it doesn't really matter.
And instead of 3 on 2 ln2, I just wrote ln2 minus half ln2. I just didn't do that.
ln2 minus half ln2. Give me a second. 1 mark. 1 mark. See that, you said, what you said gets to the part of what I've always said, the benefit of the doubt. Yours is more closer to correct than it is incorrect, so I'll have to give you 4 marks.
Alright, thanks. Yay.
But obviously we don't want to get used to that. But yeah, that's how that would work.
Yeah.
Okay, anybody else have any other questions about these? Okay, next one, or last one. By using this substitution, 2 marks only. Okay. Hopefully, are we used to, you're still missing that first line. I told you last week, memorize it for me. You're not used to changing t equals tan x on 2. You've got to make x the subject. That's a requirement. So, inverse tan, right? We shift it. Boom. Now what would you do? Times 2. Yep, perfect. Then, the derivative of inverse tan would be this, because we know the integral of 1 plus t squared, right? The integral, what we just did up here. What? The integral of 1 on 1 plus t squared is inverse tan. Oh, crap. I did not even see that. That should have been inverse tan of t. My bad. This should have been 1. This should have been 0. That should have been 1. This should have been 0. That should be inverse tan of t. I don't know why I was doing denominators. I think I was doing too many logs. Inverse tan of t, just your pronumeral. So, inverse tan of t, if you're differentiating it, it should be 2 on 1 plus t squared. Does that make sense? dt equals dx. Once you have that, now you can replace that for that. If you don't have that, you won't be able to replace. And that's why with the way you've written it, you've written everything right. Except where's your dt? You don't have any dt. And the reason why you don't have it is because you never replaced it. So you never wrote it in your working out. So be careful. Alright, sine x. Otherwise, equals 2t on 1 plus t squared. Cos x equals 1 minus t squared on 1 plus t squared. And then we can't forget, what must we do with our limits always? So when x equals pi on 2, x equals 0, t equals to 1, t equals to 0. So pretty much it should look something like this. 0 and 1, sine x is 2t on 1 plus t squared, times dx is 2 dt on 1 plus t squared. Yes? Divide 1 plus sine x minus cos x. Any questions? Divide, make it a common denominator, so it's all over. 1 plus t squared, at the top you've got to multiply by the 1. So 1 plus t squared plus 2t minus 1 plus t squared, minus 1 plus t squared. You wrote minus 1 minus t squared still. Then this and this cancels. Next line, almost there. Times, flip, 2t squared plus 2t. This and this cancels. 2 and 4 cancels. And so does one of your t's. So if I factorize this, this would have been t plus 1. So the t would cancel out with the t, in fact. That was too quick, you guys know you can do it a little bit slower. But essentially all I did was factorize. So what I've got left is 2 on t plus 1, 1 plus t squared, and I think if I'm not wrong, that was part of b, wasn't it? So that should have been the same answer as what we just had here. So it says hence find the integral. 1, 0, 2 on dt, whatever you found in double, that's why it's only worth 2 marks, I get it. So whatever the answer was in equals answer in double I. I mean that's an exam strategy for you guys to get used to. When you see part B, I, double I, triple I, it's usually a continuation of the above. It wasn't the same as I, so I'm not going to say it's always, but it's just usually, and that rings a bell. So, okay, tally up your marks unless you've got questions. I'm just going to add up. So let's move over to there. This one here, we change this.
Sam, can you scroll up so I can see the marks?
Oh, yeah. So you did, even for that one there, double line, you actually did use U sub, but we never choose U sub in the numerator. Ever. Full stop. Why? Because when you differentiate it, x squared, dx, that's what you're not writing. I can see it now. You're not writing 2x dx. Don't you? Isn't it meant to be 2x dx? And then can you see how, if you're going to get rid of x squared, that means you're trying to get rid of now your denominator, but you're never going to get dx on something. Whereas the other way around, if you chose u equals to x here, or x plus 1 even better, your du would be the derivative of x, which is dx. So you can straight away replace this. So we don't ever actually replace when we're doing u sub for numerators. Always denominators. Even here, let's look at this one. U squared would be the best substitution, equals to the bottom, because by the time you differentiate it, you're going to get x dx. Okay. So, otherwise we can go right. Good. Okay, so 1 there. 1 there. 2, 4. Yeah. Okay, let's tally up these marks. Let's get on.